are using AI and satellite data to inspect and secure infrastructure. And I'll tell you a bit more about Spacept and then about the project itself. So our inspiration were the massive climate change events that are occurring every year. Extreme weather, hurricanes, tornadoes, and mega fires. Every year it seems like there's a record fire, record storm. And at the same time, we're launching more and more satellites into orbit, and this presents an opportunity in the sense that we can monitor the Earth with an unprecedented level of resolution and frequency. Now, we started the company because of the fire that occurred in Paradise, California in 2018. If some of you are from California, you probably know very well about this fire. For the others, it was a devastating fire, and a record amount of damages occurred. And it was caused by a power line that was poorly inspected, which caused sparks, which caused the fire. And the power line was hit by a tree. Because of poor inspection, the tree wasn't trimmed properly. And in high winds, it hit the line, and that eventually led to the fire. 85 people lost their lives, thousands of buildings destroyed, billions of dollars in damages, and the company itself went bankrupt. And we were thinking, what if we can use a space technology to prevent this? And as you can see in the images, you can see the power lines in a very high level satellite image, and in a detailed one you can see the damage to the buildings and essentially how the Paradise fire was wiped out. You can see how the wind moved the fire towards the southwest, and it turns out that we can actually do it and from space, and we can do it better than the current means. So traditional means are very expensive and slow. That's why they're not very effective against these new types of climate change events. So combining space data with artificial intelligence provides a very good solution for this challenge. And if I were to open this link to a quick demo, you can see kind of how this works in practice. We ran the analysis in France for a company over there, and we inspected a section of their power lines. And this is a dashboard that shows you the results. In blue you see the power lines, the images are sections of the satellite data, and in red you see high-risk areas, so areas where trees are very close to the lines. In yellow they're further away and they don't pose as much of a problem. And power line operators can simply run our analysis on their entire lines, so hundreds of thousands of kilometers, instead of sending a helicopter or a drone to inspect it. And it is a process that can be done on a country level scale in a matter of days. So quite powerful. Subsequently, after the inspection is carried out, repairs crews, helicopter crews, and drone crews are sent to investigate further and to resolve the issue. It's a huge market, and the same technology can be applied for pipeline inspection as well, and it can be expanded in other areas of infrastructure inspection. Infrastructure that these days is more and more at risk due to climate change events. It was started by me and Arshak and Eric from Sweden, and we're joined by 20 plus folks from around the world, students mostly. And we take an open innovation approach. So instead of building walls again around what we do, we make everything transparent, and everybody can contribute and collaborate, because what we really want is to address climate change issues on a global scale, and be as impactful as fast as possible to save lives. So this is where the Hackbridge AI projects come in. Initially started with Cambridge University, with a couple of students there. We expanded to a larger team, and then included students from UC Berkeley this semester, as well as Cambridge, Carnegie Mellon, and Imperial College London. So we are bridging, essentially, we're making a collaborative bridge across the world in terms of students working on this AI project. So what we came up with is a disruptive change detector. So totally different from what we are doing normally, so power line vegetation inspection. We built an unsupervised model to detect oil spills, because this is also a major issue, and it's contributing to climate change, it's devastating ecosystems. And as a scuba diver myself, I really want to prevent oil spills from endangering more the wildlife. So these are satellite images using the European Space Agency Sentinel, and you can see images from an oil spill that occurred last summer in Mauritius. This is a zoom-in version, colored, of the ship broken, and you can see the oil. And from radar you can see the oil quite well. Now the question is it possible to use this in order to automatically detect oil leaks that go unchecked for weeks and months, because they're from platforms that have been used, have been secured, but they're unmanned these days, or pipelines that are going across the desert or across mountain ranges, and nobody's actually monitoring them with a high frequency. This way we would be able to monitor hundreds of thousands of kilometers every week, and when an oil spill is detected, or a potential oil spill is detected, crews can be alerted. So we started from humble beginnings with this cartoon image to see how well we can detect changes, and you can see this is the change map in the image itself, detected using an unsupervised model that we have developed from a couple of papers put together. And this is an example of how it works on a satellite image, where a lake is evaporating and then going down again. I'm gonna run quite quickly through these, but essentially we started from raw images, we normalized them, we denoised them, we implemented an unsupervised algorithm, as well as supervised algorithms, so CNNs, autoencoders. We tried pretty much all of the state-of-the-art in the field, and we ended up with this approach, and these are the masks. So we annotated a couple of images from that oil spill, and then you can see the results of the unsupervised model over here. And this is how they progress as our models got better and better. You see less and less red areas. So this is now going to be applied by stakeholders around the world to secure their infrastructure, and it can be even used to detect broken light bulbs by using nighttime satellite images. These are our partners, and we're backed by the European Space Agency, and we hit the news with similar projects in the past, and we're happy to have anyone interested join us in future projects as well. So that is the two sides of the worlds I've been involved with, some fun projects that I care about involving data science, and I'm looking forward to your questions. If Gather Town is collaborating. So yeah, please feel free to unmute yourself and ask away. I'll stop the recording.